Hi, so we will talk about the determination of alkaline percentage in hygiene product. Hi, so these our group members, which is first is Vincent and Lik Yang, and second is Sifan Demian bin Muhammad Fauzi, and is me Muhammad Aziz Shambiasan, and third is Syed Wafi Al Hadi bin Syed Said, and lastly is Muhammad Syafiq Daniel bin Muhammad Syafiq. Hi, so now we can see or look the introduction, which is understanding the alkane levels in hygiene product is crucial, especially when it comes to keeping consumers safe and ensuring product work effectively. Items like soap, shampoo, and detergent often include alkaline ingredients that help clean and lift away dead and oils. But if the alkalinity is too high, it can cause skin irritation, allergic irritation, or even harm delicate surface. As a university student, diving into the analysis of these products allow us to appreciate the science behind the everyday item we use and highlight the need for quality control in product development. This presentation will delve into why alkalinity matters in hygiene products, the techniques used to measure alkaline levels, and how this knowledge can lead to safer and more effective formulation in the health and personal care sector. Now, we look at the purpose. The goal of this study is to find out how much alkalinity is in different hygiene products like soap and shampoos. By checking their alkaline levels, we want to see if these products are safe for human skin. Knowing the alkalinity of this item is really important for keeping use safer, avoiding any skin irritation, and ensuring that personal care products are formulated correctly.
Alright, Assalamualaikum warahmatullah. So I'm gonna explain to you guys the theory. Okay, alkalinity refers to the ability to neutralize acid and is primarily due to alkaline substance such as hydroxide, carbonates, and bicarbonates. In cleaning products like detergents, shampoos, and soaps, alkalinity plays a significant role in cleaning efficiency, saponification, and protection. Excess alkalinity, however, can be irritating to the skin and can cause damage to hair or sensitive materials. The determination of alkalinity in such products is usually done by acid-base titration. This entails slowly adding a known volume of a strong acid, usually hydrochloric acid (HCl), to a known volume of the sample until a neutral solution is obtained, as determined by some suitable pH indicators such as phenolphthalein or methyl orange. The quantity of acid required to reach the endpoint is then employed to calculate the quantity of alkaline content in the sample. This technique assumes that the alkaline reagent in the sample are either strong or weak bases that dissociate completely or partially in water. The findings are expressed as percentage alkalinity or an equivalent of now per gram of sample, depending on the procedure employed. Monitoring alkalinity is important to ensure that the product is safe and perform effectively without risking any harm to the users.
Next up, I will explain about the methodology. So first thing first, the sample preparation. You must begin by accurately weighing a known amount of the hygiene product such as soap or detergent using an analytical balance to ensure precision. And then we must transfer the weight sample into a beaker or conical flask. And then we must add a suitable volume of distilled water to dissolve the sample completely. And lastly, we must stir the solution thoroughly with a glass rod or magnetic stirrer to ensure that all alkaline components are dissolved, resulting in a homogeneous solution that ready for a titration. So next is the titration procedure. First thing first, we must add a few drops of phenolphthalein indicator to the prepared solution. This indicator will help to detect the endpoint of the titration. And then we must fill the burette with a standard hydrochloric acid solution of known concentration. And then we must titrate by slowly adding HCl from the burette into the solution while continuously swirling the flask to mix thoroughly. And then carefully observe the color change during the addition of acid to avoid overshooting the endpoint. Lastly, we must record the volume of hydrochloric acid used once the endpoint is reached. And then next up is the endpoint observation. So the endpoint is observed when the solution changes from pink to colorless. Phenolphthalein is pink in basic alkaline solution and turns colorless when the solution becomes neutral or slightly acidic. This color change indicates that all of alkaline substances present in the sample have been completely neutralized by the acids. And then for the additional notes, it is important for us to perform the titration slowly near the endpoint to obtain an accurate result. And then we must ensure all glassware is clean to avoid any contamination and error in our results. And then multiple titration trials may be conducted to obtain consistent and reliable data.
There are mainly 4 types of titration, that is, acid-base titration, redox titration, complexometric titration, and precipitation titration. Well, let's jump right into them. The first type of titration is acid-base titration. It is the neutralization between acids and bases to produce salt and water. There are 2 types of acid-base titration, strong versus strong and strong versus weak. Strong versus strong is the type where strong acids and strong bases neutralize each other until the equivalence point. That is, the point where the number of moles on both sides are equal. For strong versus strong, the equivalence point will be around pH level 7. Any more of the titan is dropped will make the pH lean towards the pH of the substance used for the titan. Meanwhile, strong versus weak is when a titration between strong acids and weak acids happen, or vice versa. The equivalence point of a strong versus weak titration depends on the pH of the strong substance. If it is the acid that is strong, it will lean towards lower pH and vice versa. The second titration to be discussed today is redox titration. It involves oxidization and reduction reaction between what usually are ionic pairs. The reagents used are permanganate titration, dichromate titration, and iodometric and idiometric titration. Here are how electron works in redox titration. The sodium donates electron to the chlorine ion. Next is complexometric titration. Complexometric titrations are used mainly to detect metal ions by the use of complex forming reactions. Normally, the titan used in this titration is ethylene diamine tetraacetic acid, or EDTA, and the indicators used are areochrome black tea, calmagite, and xylenol orange, and many others. And lastly, precipitate titration. Precipitate titration is the formation of insoluble solid when titan reacts with analyte. This method relies on a complete precipitation reaction to reach the equivalence point. The indicators usually used for this titration is potassium chromate.
So we look into the example, titration of alkalinity in soap. The objective is to determine the percentage of soap alkali as sodium hydroxide in a solid soap sample using standard hydrochloric acid titration. For apparatus and reagent, we have soap sample will require 5 gram of it, 0.1 mole hydrochloric acid, phenolphthalein indicator, distilled water, burette conical flask, pipette, beaker, and glass rod. For the titration result, we'll go through 3 trials. The first trial, the initial burette reading is 0, final burette reading is 15.2, and the volume of HCl used is 15.2. The second trial, initial burette reading is 0, final burette reading is 15.3, and the volume of hydrochloric acid used is 15.3. The third trial is initial reading of burette is 0, final burette reading is 15.25, volume of HCl used is 15.25. So after calculation, we know that the soap sample contains 4.88 free alkali sodium hydroxide by weight.
So, before we end the discussion, here a simple conclusion. Volumetric analysis in the form of acid-base titration is a fundamental analytical chemistry method used in determining the concentration of an unknown solution through precise measurement of volume. For hygiene products, the method can be utilized to precisely ascertain alkalinity such that hygiene products like soap, shampoos, and detergent are safe and effective for use on a daily basis. Analytical chemistry plays a crucial role in the maintenance of products' safety and quality. It measures chemical components and quantities. Manufacturers meet regulatory standards, avoid harmful formulation, and delivers maximum product performance. However, some issues may affect the reliability of the outcome. There are sampling errors, failure to fully dissolve the sample, and difficulties in identifying the true endpoint, especially when the naked eye is employed. Despite this, volumetric analysis is a safe and widely used method in consumer and industrial product quality control. So that's all for our discussion today, and we hope the discussion we deliver to the audience can help in their daily basis routine. Assalamualaikum.